Hey guys, and welcome to Functional Print Friday. Hashtag not Friday because it's Sunday and this is not a functional print video. It is going to be a review and fix video for this Neptune 4 Max printer from ELEGOO. And one thing I want to say right away, this is not a sponsored video. I paid full price for this printer and I've actually owned it for a while. And I've been wanting to do a review video on it, but I've wanted to wait until I figured out all of the issues on the printer that was keeping me from, well, using it. If you're not interested in the review and you want to just skip right to the fix, just go to this time here and that'll be just me talking about the fix for this printer. All right, one thing I want to get out of the way right away in this review video is tackling the question of, is this a good first 3D printer? And no, it is not. By no means should you buy this printer as your first 3D printer. It's going to be a very frustrating experience. This printer is really targeted at people that are familiar with the hobby. They're probably looking for something that runs Clipper, and they're looking for something with a really big build volume. And I think it is still the right fit for that crowd, but there is some issues with this printer. Its biggest success story of having this huge build volume is also its biggest downfall. And we'll get to that later on in the video because it is the source of 90% of the issues with this printer. All right, let's talk size first. This printer is absolutely huge. In fact, I've taken the camera out of the tripod just so I can pan up and down and show you the whole thing, because there's no position in this room where I can even keep the camera in the tripod where you can see the whole printer. And just for comparison's sake, I've lined up the edge of the build plate here for my Prusa Mark III at the corner of this build plate, and you can see just how big the build area is on this printer. It's 420 by 420 by 480 in the Z. And that's a lot of print volume. And let's be honest, it's probably the main reason that you're looking at this printer. Okay, let's talk hardware fit and finish and price on this machine, because I do actually think you're getting a lot for your money on this machine. It's priced at $470 US at the time of this review video, and the construction on it is very good. It's primarily made from these aluminum extrusions that are pretty common in 3D printers nowadays. They've anodized everything to match in this nice sort of matte dark blue color. It truly looks really good, and the frame on the printer is very rigid. The gantry is so tall, they've added these struts that run from the top of the gantry down to the back of the frame, and we can see that even though the frame on the bottom is covered with this sheet metal panel just to keep things nice and clean looking, the frame itself is this extruded aluminum that runs along the bottom as well. The machine comes standard with a touchpad, and it's actually on sort of this like coiled up phone cord. I've got most of mine tucked underneath the frame here, and it's magnetic on the base. So you can actually pick this up and hold it in a comfortable position if you want. I find I don't really do that much. For the most part, it just stays down here on the base. From a network connectivity perspective, we have both wired Ethernet and Wi-Fi come standard in this machine, which I think, again, for the money, I think it's really nice. If you're looking at this camera, wondering if that comes with it, it does not. I do have a separate video on this. I designed this camera mount that goes over this side of the end of the y-axis and holds a standard USB webcam. I'll link that video down in the description of this if you want to check that out, but this machine does not come with a camera. From a USB connectivity perspective, we have a single USB port, and this connector on mine just runs down underneath the machine and then connects over to the USB cable for that webcam. This USB-C port over here is not a regular USB port. It's used only for serial connection to the printer. And while we're here on the front, I didn't actually notice this till I'd even had the machine for a couple of days. It's got a cute little drawer up here on the front. I don't know what she'd put in that, but they even bothered to put magnets in it so that as it goes all the way back, it stays locked in place. This machine uses palm wheels on the X and Y axis for movement. These palm wheels key into, they key right into these angled faces on the aluminum extrusions for each one of the axes. And I was worried about this when I got the printer. I've heard horror stories about the dust that comes off of these palm wheels. That hasn't really been my experience when I was, I'll say, breaking in the printer, like call it the first 20 hours of use. I had a lot of dust accumulating up here, and you can see some here. There's a little bit, but these were covered. Like, there was a lot of it, and I thought, oh yeah, this is no good. I'm gonna have to replace these with linear rails eventually. But I think a lot of that is just the initial break-in of the wheels as they sort of, the surface on the wheel that touches the extrusion rubs off a little bit until they kind of fit together perfectly, because I vacuumed this off, I don't know, probably 50 printing hours ago. And I've only got just a little bit more that's accumulated on here. And I've read that as well. A lot of people say, yeah, you get a lot at first, but then once everything fits together well, unless you're constantly tweaking it, taking it apart, it's generally pretty good. And that's been my experience so far, but I can see that as a downside versus linear rails, which are, going to add expense to this printer. But so far, I don't really have any issues with the palm wheels. The machine comes with this giant part cooling fan that attaches to the back of the X-axis, and there's 2 squirrel cage fans in there, and they spit the air out in this thin curtain from these long rectangular nozzles here on the bottom. And it does move a lot of air, but it is pretty loud. Here, I'll flip it on. The printer comes standard with LED lighting on the upper gantry of the machine. There's also a small LED light on the extruder that lights up the area directly below the hot end that you can turn on. And it does a really good job illuminating around the printer. If I was to turn the lights off in this room, we'd still be able to very clearly see the build plate on this printer and the whole surrounding area. Moving the bed out of the way, we can see that we've got a nice piece of thin sheet metal here that sandwiches the power supply and the control board for this printer inside this whole area. If I was to flip this machine up, you'd see there's another piece of sheet metal on the bottom. So the area where the power supply and the control board for this printer is completely enclosed, keeps the dust and dirt out of it, keeps kids' fingers out of there. That is very well executed in my opinion. Speaking of boards, this machine runs Klipper out of the box. It is a slightly customized version of Klipper, but you're getting pretty decent control hardware in here as well. And that bed on this printer is gorgeous. It is a really nice full-size PEI sheet. I've had no issues with the build plate on this machine at all. Another thing worth noting, this machine does have a filament runout sensor. It's mounted up here on the top. It's hard to tell because it's mounted in such a way that it can move quite freely, but this part is actually mounted to the spool holder. So when you put a new roll of filament on this machine, you feed it through this first and then down into the actual extruder. Okay, so with all the hardware basics out of the way, let's talk about actual user experience on this machine. And that's where we start to run into issues. ELEGOO ships Cura with this machine. And the thing is, no one really uses Cura. I don't use Cura. Let me know down in the comments if you're all about Cura. It has very little market share in 2023, 2024. Most people are using OrcaSlicer, SuperSlicer, OrcaSlicer. I'm willing to bet there's probably as many people still using Simplify 3D as there are people using Cura. And I say that's a problem for the user experience because right out of the bat, even if you're familiar with other software, it's almost guaranteed not to be Cura. So you're starting off with software that you don't know how to use. And I guess if it's your first 3D printer, well, you're starting off with software that you don't know how to use regardless, but Cura is probably not the best software to try as a beginner. At the time of release on this machine, they also only supported a really old version of Cura. I think it was 4 dot something. They are now offering a 5 dot version of Cura, which I believe is the newest version of Cura, including a good profile for this machine. So, if you use Cura, you're probably going to be happy with that. I don't use Cura, so I started my user experience with this printer of trying to get a working profile for it for OrcaSlicer. And that's the thing. I don't understand why 3D printer manufacturers do not just release official tuned profiles for the popular slicers for their printers that they're actively selling, ones that they're actively still shipping today. Because, again, no one really uses Cura. So we're all just left to either use someone else's profile or develop our own profile for the slicer of our choice. I wanted to use this printer with OrcaSlicer. There is a profile in OrcaSlicer that works, but it's not perfect. I've tuned mine quite a bit, and I will share my profile for this machine. But before I can do that, we've got to get into talking about some of the other issues on this machine. Okay, let's talk firmware, or firmwares, because there's actually 2 different firmwares on this machine. There's the firmware that runs on the control board inside the machine, and then there's firmware that runs on the touch screen. And out of the gate, ELEGOO had a number of issues with the firmware on this printer. The biggest problem was the firmware that shipped on this machine did not remember the Z offset after a power cycle. So you'd have to set the Z offset on this machine every single time you power cycled it, which is a real pain. And there was other issues with that original firmware as well, or maybe not the original firmware, but the firmware that was still shipping on this machine as of December of last year. I purchased mine right around Christmas 2023 last year. and out of the box it did not remember the Z offset. Now I have updated the firmware on it, and they did resolve that, and they resolved a couple of other issues as well. I still do have the occasional case where it seems to lose the Z offset, but for the most part that seems to be working okay right now. But I said firmwares, and that's because we have separate firmware running on the touchpad, and they have to be updated independently. They have to be updated in a very specific order. And to be fair to ELEGOO, if you follow the document that they publish on how to update the firmware on this printer, you'll do fine. The thing is, there's like 20 steps, and you genuinely do have to do their 20 steps in the order in which they give it to you. I had to, now they did include a USB drive for this, but I had to take that USB drive, load a specific set of files on it in a specific folder, in a specific order, put it in the machine, power cycle it, let it go through like a patch process, then take that USB drive, clear it off, put other files on it, put it back into the machine, update it again, because the first is just like a patch that makes it possible to get to the newest firmware. You go through all that, but you're still not done, because you've actually got to take the touch screen over here. If I take this out and I flip it over, you can see it's got 4 screws in it. You actually have to take this apart, fill that USB drive up again, pull the SD card out of the USB drive, put the SD card into the circuit board in the back of the touch screen, and update the firmware on the touch screen as well. Right now, there's probably, the audience I'm guessing is probably split. Half of you are going, that's not so bad. That sounds like my experience with 3D printers in general for the last 5 years. And the other half of you are going, what the heck, on my Bamboo Lab printer or my XYZ printer, I hit a button, it updates the firmware, it tells me it's done, and life's good. But I got news for you guys that are over here in this camp. It's 2024. That type of thing is just not acceptable anymore. We should be able to update firmware by clicking yes or going through one step. It's ridiculous to have to go through 20 steps to update the firmware on a printer in 2023, 2024. Yeah, I know, some of us are way spoiled over here and the Bamboo just does it. I just say yes and then it tells me it's done. But this is not the middle ground. This was still a fairly convoluted, complex process to update the firmware on this printer. Another issue that's plagued this machine, and I have to say mine is perfectly fine, but I've seen a number of cases out there of folks that seem to have received machines that are just not very well assembled. Again, there's not a lot to do for assembly on this machine. It ships flat packed, so you do have to install the gantry and connect some wires. It's not a long process to do it, but everything else is pre-assembled, and adjusted as well. So the eccentric screws on the palm wheels to bring everything into position for all 3 axes, all that stuff was already done, and it's very good on my machine. I have no complaints, but I have seen several issues of people showing their bed actually moving from side to side, not all of the wheels turning on one or more of the axes. Again, I don't have any of those issues on mine, but quality control should be picking that stuff up. And to be fair, some of these people might have read someone else's suggestion on adjusting it and got it way out of adjustment and then posted the picture or video saying, how do I fix this? I don't know. But there are reports out there of folks that have received these machines out of the box with not everything as tight and tuned as it really should have been out of the factory. Okay, let's talk bed leveling. We already know this machine has a huge build platform on it, 420 by 420. We know we're not going to get away with a build surface that big without doing bed leveling. And this machine does have a sensor on it in the extruder. But that sensor really just gives you an idea relative to the other points that it probes what the difference is. It doesn't know how far the nozzle is away from your build plate for a couple of different reasons. First of all, because there's just other things that are going to vary and change that reading. And secondly, because not every build plate is going to be exactly the same thickness. It's not a touch probe. A lot of the newer printers are using a touch probe where they're actually either touching the nozzle gently into the build plate, or they have a probe that is actually contacting the build plate to know exactly how high above the build plate it is. This does not have that. It's only able to determine the height of different points on the bed relative to the center height of the bed. So there's 2 things you've got to do. You've got to do the leveling so it can figure out relative to that center point how high or low the rest of the bed is, and then you've also got to set the Z height, the distance that you want the actual nozzle of the printer away from the build plate. That's done manually. Not a big deal. You generally do it once. As I mentioned before, the early firmware on this printer would lose that setting, so it does become a pain when you have to keep resetting the Z height, but that is largely fixed today. So the printer does have the ability to access the bed leveling and kick off a bed leveling, or really reading all the points on the bed right through the touchscreen if I was to access this level button here. Now I can't go through with it because I've got a part still on the bed. It's not going to be able to home with that on there. It's going to crash into it. But it opens it up, it heats up the heat bed, and then immediately starts probing. I think it's 111 points in a mesh on the bed, and it'll save that mesh when you exit out of the menu. Now you do need to make sure you actually load that mesh before you start printing, and that's another challenge with this machine, although I can't really blame ELEGOO on this one. I think the bigger issue there is that folks are using profiles and other slicers, and they're not making sure that that actually is in the starting G-code that their slicer is sending is the command to load the mesh profile. But I'm going to talk about that some more because I actually don't think you should be loading the mesh in your G-code. We'll get there. Stay with me. Now, ELEGOO gives you 6 knobs in total. You can see the 3 running down this side of the bed. There's 3 more over there. And the idea is when you're in the leveling screen, you can bring it'll actually bring the hot end over and drop the nozzle close to where the screw point is. And you can turn the knob and try and get it close, again, with your sheet of paper relative to that center point. It's confusing because it also ends up slightly changing the height to what you had just set to your Z height. In short, it doesn't work very well. You're wasting your time trying to use their inbuilt tool to physically adjust the height of your bed with these knobs. There is a macro add-on for Clipper called Screws Tilt Calculate that makes it way easier. It'll actually go and measure those points and then tell you how many degrees you need to turn each one of these knobs. Actually, and it specifies the degrees in minutes, so you can kind of imagine it on a clock face. That's not perfect either. A lot of people end up chasing their tail, and again, that's going to make a lot more sense later on in this video when I talk about the fix for this, because I had the same experience. I got the Screws Tilt macro on here, I ran it, I moved the knobs as much as it suggested I do, and then I ran it again, and in many cases it wanted me to move the knob the same amount of minutes that I just moved it. Not always, and this went on for like 40 minutes until I got everything to within, I think, 1 degree of recommended movement, and I stopped and I left it. And then the next day I ran it again and they were all off. And honestly, at that point, I probably should have realized what's going on with this 3D printer, but I didn't. It took me several more weeks of thinking about it to figure out what's really happening here. So if you skip to this part of the video, I'm going to guess you've probably got one of these and you've gone through a lot of the same challenges that I have. You've probably been in the ELEGOO Discord. You've probably been in the ELEGOO subreddit. You follow a lot of the steps that people have suggested. And I'll briefly walk through the things that I did. I did the Screws Tilt Calculate. I got my bed to as good of a variance as I could get it to. I think it was 0.17, if I recall. And I updated all the firmware, updated the firmware in the printer, updated the firmware in the touchscreen. I got the most recent version of the profile for the printer for OrcaSlicer, and I tried PurgeSlicer as well. I set the Z height a couple times. I tuned my extrusion. I tuned my Z height. I tuned linear advance. I did all of the calibration things that you can do inside of Orca. And for this test print that's on the bed, I've got several of these. The best result that I could get is this guy right here. And honestly, this is one of the best ones. All of the corners of my prints and even sometimes sections of like the middle parts still had terrible over extrusion. And this is truly the best one. This was one where I ran a bed level directly before the print. I put the G29 for the bed leveling right in the G-code, the start G-code, so that it did a full mesh leveling right before this print started, and I still had really poor extrusion on parts of the print. And honestly, it's sad to say, but I was actually happy with this print at the time because it was so much better. I had several that I couldn't even finish. It would get up to doing the top layers, and there was so much over extrusion. I was worried I was going to end up with a blob of death on the printer, so I stopped it. And I did print 2 or 3 out like this one. I kept the best one to show you. And all the corners basically look like this. Hopefully the camera's picking that up. I think we can all agree there's a ton of over extrusion there. But take a look at these other ones. A little bit better. Almost all the way better. And then if we take a look at the one on the bed, this one's basically perfect. So how did I get here? Well, I mentioned one thing that I did was I added bed leveling to the beginning of every single print. Yeah, it's a pain. It takes the bed like, I think, I don't know, maybe 5 minutes to warm up. And then it takes to do, I changed my mesh to a 9x9, and it still takes almost another 10 minutes for it to run the full mesh leveling. So now we're talking, I don't know, 10 to 15 minutes, depending on how long your bed warm up is, depending on the ambient temperature in your room, before it even starts printing. But you know what? I was okay with that. I mean, my Bamboo machines run a full mesh bed leveling before every print, and their beds are way smaller than this. Seems like that's probably a pretty good idea. So I did that. Again, I got that quality of print, which I viewed as a significant improvement. I still wasn't happy with it, but again, significant improvement. But it just kept eating at me. Why is this happening? How could the extrusion be so far off in parts of the print when I did a mesh level right at the start of the print? Like right before it started actually running the G-code to make the part. I thought about that for a while. Honestly, weeks it was eating at me, where I did make a couple of these to use down here in my basement, but I didn't run any other prints on this machine because I just didn't feel like I had it dialed yet. And then one morning, it clicked. I must have been troubleshooting it in my sleep, like in a dream, because one morning I woke up and I had a theory about what was going on here. And I got right to action to test that theory. Let me pull this part off the bed. Okay, I popped that print off the bed and I stacked it over here on the other test prints, and you can see just how much of a difference there is in these 4 prints. You can see how bad the over extrusion is down here, and this is by no means the worst I was getting. The other ones were so bad I had to stop the print before they could finish, and they get progressively better as we go up the stack here. And remember, even on this one that I was happy with at the time, I was doing a full mesh bed level right in my G start code, my starting G code. It was warming the bed to 60 degrees, running a G29, which kicks off the mesh bed leveling, and then it keeps that mesh loaded for that print. So this print, in theory, should have been perfect, because the printer at the start of the print job had an accurate idea of where the height of all the points on the bed was relative to the center point. And the center point's good. You know, we look pretty decent there. So what's going on? Well, in addition to 3D printing, I also do a lot of hobby machine work with a lathe and a milling machine. And one of the first things that you learn when you're getting into machining is that nothing is rigid. Treat everything like it's made of rubber. And that was the aha moment I had when I woke up that day on this machine, is that everyone's just assuming that we turn our knobs, we get everything level, and that's where it stays. And that's where people are getting it wrong on this printer. Let me grab something, I'll show you what I mean. Okay, I've got you back on the tripod so I can bring in a piece of equipment. So this down here is a 246 block, and I'm using this basically just as a big heavy block to give me a stable surface to put this indicator stand on. And down here at the end we have a dial indicator that is capable of reading in tenths of a thousandth of an inch. So a tiny amount of movement is going to move this needle. So let me get this down positioned on the bed. Okay, I've got this set up and pretty close to zeroed out. Let me explain what's going on here, what I'm trying to measure with this setup. So this is a dial test indicator, and it is measuring the position of that tiny little dot that we see there at the end in the z-axis. So it's measuring downward motion and it's measuring upward motion. So if I push down on this, you'll see that indicator go down, and as I release my finger pressure, it comes back up to roughly 0. So you see what we're measuring now. It's measuring basically movement in the z-axis of the build plate. And it's not taking a ton of finger pressure to push on this, so that already indicates to me that we don't have a very rigid surface here. But watch what happens when I turn the heat bed on. So I'm going to set this to 60 degrees Celsius, which is the same temperature that this bed would heat up to for a PLA print, or the same temperature that the printer heats it up to if it's measuring a mesh bed leveling. So watch what happens as soon as I hit this OK button. Yeah, you seeing that indicator move? I think what's happening is, I think the center point of the bed is warming up faster than the rest of the bed. And so the material in the center of the bed is expanding at a rate faster, because as things heat up, they're going to expand. So it's expanding at a rate faster than the further points on the bed. Okay, I'm switching over to a video that I recorded earlier that has a stopwatch in it, because I think it makes it a lot easier to understand what is happening here. So I go in and I set the bed at 60. Okay, so here we are at 58 degrees Celsius. And why did I stop the video here at 58 degrees instead of 60? Because the firmware of the printer waits for the set temp to get within 2 degrees Celsius of the set point, at which point it will start proceeding forward. So this is the point at which this printer is now going to start actually executing the rest of the G-code to make your part. But look where we are. We're just over 2,000ths of an inch lower than where we think we are. So when that first layer goes down, it's going to look like it's under extruded, or it's going to look like your bed level is too low. So maybe you go back to screws tail calculate, thinking you must have missed something. Maybe the mesh didn't get saved. Maybe the mesh didn't get loaded. No, the bed was just 2,000ths of an inch lower than where you expected it to be, because the center of the bed is heating up faster and it's pushing the edges down. Now, 2,000ths of an inch might not sound like that much, but in metric, that is, I think, around like 0.05. So about, if you were doing 0.12 millimeter layers for your layer height in this print, the bed has moved about half of the layer height. So clearly you're not going to get good extrusion. Depending on where you have your overall Z height set, it might look over extruded, it might look under extruded, and it's not going to look over extruded or under extruded relative to other areas on the bed. So again, this is what's happening if you've loaded your mesh bed level, you heated the bed to 60, the job started, right? Okay, well, what happens now throughout the print? Well, this does eventually cross 0 again. And I say cross 0 because, see, let's let this play. It's moving, it's moving, it's moving. I'd say right about there. 8.5 minute mark. This part of the bed is now back to where it should be. All right, well, several minutes have passed. So depending on what your print is, like how big of a surface area it is, we might not even be on the first layer anymore. So if we happen to put the first layer down over here, and now we're trying to put the next layer down here, again, the bed has moved half of your overall layer height on a 0.12 millimeter print. So it's not going to be great. This area is already going to be looking probably, pretty rough. But let's watch what happens as we keep going. Oh, interesting. It keeps going and keeps going and keeps going until it finally levels out right about here at about the 27-minute mark. Let's call it 30 minutes, because it's probably going to vary a bit depending on what the ambient temperature in your room is. It settles down over here to a little bit under 2,000ths of an inch. But that's a pretty big difference, because remember, your print started over here at 2,000ths of an inch under where you expected it to be. So there's now a delta of 4,000ths of an inch in height change in this bed, which would represent an entire layer if you were doing 0.12 millimeter layer height. And if you're doing 0.2 millimeter layer height, it's still half of a layer. There's no way you're going to get good extrusion. Your extrusion would have to be set at 50% to get a good layer on the top if you only have half the distance that you anticipate having between the surface of the print and the height of the nozzle at that time. Okay, now that we know what the actual problem with this printer is, in that the heat bed takes a full 25 minutes to saturate and stop moving around like a sheet of rubber or a wet noodle, what can we do about it? Because if we do nothing, we're going to just continue to have over extrusion, under extrusion, layer shifts, all the things that we would expect to happen if the nozzle is just simply at the wrong height over the print. So the easiest answer is we wait for it. We wait for that heat stabilization to happen across the full print bed. And that's what I'm doing with this line here in my starting G code. G4 tells the printer to wait, and in this case, we're telling it to wait this number of milliseconds, which works out to be 25 minutes. Now, feel free to tweak this. If you have a fairly high ambient room temperature, you might be able to make this number 20 minutes. Or if you're printing in a pretty cold room, you might want to go longer. My room, the ambient temperature generally sits around like 65, 67 degrees. I found 25 minutes is enough for me, but if your room temperature is a lot cooler, you might want to make this longer, maybe even 45 minutes. The second piece of it is, because it is such a big bed and we know that it moves so much with each heat cycle, I don't see any way to get around doing a mesh bed leveling before the start of every print. That's the only way to know where all those other points are in the bed relative to that center point for that specific heat warm-up cycle. So let's just step through the G code because there are a couple other changes I made in here as well. So I initially set the nozzle to 140C, but I don't wait for it. I just tell the printer like, hey, start warming the extruder to 140 because we really don't want to get that nozzle even close to the bed until it's warmed up, because if there's any hard plastic on there or, you know, dingleberries from the last print, you're liable to actually physically contact the bed with those in the leveling process, and we don't want that to happen. So warm the nozzle up to 140. Now, we set the bed temperature with an M190, and it's important that we use the M190 to the bed temperature initial layer. Now, this is a variable in OrcaSlicer. You may need to adjust this to be the actual set point, but I am setting it here with a variable because if I'm printing a different material and I'm not going to target 60C for that bed, it might not move in the same way at that higher temperature. So let's say I set this at 60. We do our mesh bed leveling at 60, but then we get to the first line of the print and it sets the heat bed at, I don't know, 80 degrees C. Well, that bed's probably going to move again. And now it's not in the right position for where we wanted it to be for that print. So instead, by using a variable here, we can tell the printer, yeah, let's actually look in the G code for the initial layer and let's warm the bed up to that point. And then we wait for it. Nothing happens until the bed reaches that 60C. Once it reaches the 60C, we now wait 25 minutes. So reality, the 25 minutes here is closer to the 30-minute point in the video, because the video, I started it at the moment I turned the heat bed on. So we're not even getting to this wait period until it reaches the 60C. So treat this as more of like a, I don't know, 31-minute wait from the time that you first started the print. Then the next one goes into the auto bed leveling. G29 is what kicks off an auto bed level on the printer. And this is going to run the mesh however you have it set in the printer.config file. And I'll put mine up on the screen because there are two places that I changed in there. I changed the mesh from 11 by 11 to 9 by 9. Yeah, 11 by 11 would be better, but it's going to take even longer to run. And I'd much rather run a 9 by 9 before the start of every single print than run an 11 by 11 or even a finer granularity mesh, just once in a while. Because again, I may as well throw that mesh out. It's only a point in time capture of what the height of the bed was relative to the center point at the moment the probe was there. All right, let me just show you the other sections in the printer.config that I'm talking about. And again, you don't have to try and pause the video and retype this stuff. I will put this, it'll either be down in the description of the video or on a page that I link in the description of the video. But I'm gonna scroll down and I'm gonna find the section that says G-code macro G29. So this is where I changed this to be probe count 9. It was originally 11. So I'm actually being a little bit less granular, going down to 9. But again, I'm running it before every print. I think that's a good balance. If you want to leave this at 11, that's fine. It's just going to take even longer to run that mesh bed calibration. The other things that I changed are down here in probe and bed mesh. I set the samples to 3. This was originally 2. and I set the samples tolerance to 0.01. This was a lot higher before. I don't actually even remember what the original value was, but it was accepting way too much of a variance in your measurements over the same point on the bed. So I would recommend moving this down here. I do see mine occasionally rerun. If it runs a 9x9 mesh, there's usually 1 or 2 points where it'll say, you can see it right in the console, it'll say that the measurement is too far off and it's going to rerun. And it doesn't take that long to redo it. You know, if it reruns 2 or 3 of those spots, you're adding a couple of seconds onto that mesh bed leveling. The other thing I changed down here is I actually defined the probe count as 9x9 down in bed mesh, and this was originally 11x11. The other thing that I changed was, I don't know what the starting G-code is in Cura. I've never even installed or used Cura. I can say the Neptune 4 Max profile that is in OrcaSlicer at the time of this video is released. It draws the purge line down in the center of the bed, in that sort of same area where you'd grab it with your thumb and forefinger to lift the bed off. The problem is the printer can't get outside the build area on that part of the build sheet. I don't know why that's where they're trying to draw the purge line, because you're drawing the purge line in the printable area. The printer will go outside the build area on the left side or the right side of the sheet. So I have mine adjusted that I'm actually drawing my purge line on the left side of the bed outside of the printable area. So I don't have to wait there at the printer for it to draw the purge line and then quick get it off the bed with a scraper before it goes over it with part of the print if I'm using the full bed volume. Oh, one thing I realized I forgot to talk about was the differences in those test prints. So there wasn't just 2 there, like a good and a bad, there was 4. So there are a couple other things that I did end up tweaking throughout the process to get to that final finished product that was perfect. The second one that looked better, but still not great, I was waiting only 10 minutes for the bed temp to stabilize, and I had the part cooling fan on. And the reason I only waited 10 minutes is because the majority of the movement does happen in the first 10 minutes. I think it only moves maybe one more thou in the remaining 15 minutes until it finishes, fully stabilizing. So I didn't want to wait. I set it to just 10 minutes and ran a job, and it improved, but it didn't look great. And I remembered seeing how much the bed still moved after the part cooling fan turned on. So I ran the job again with the part cooling fan off. And that was the third of those test prints that looked almost perfect, but wasn't quite right. It still had some over extrusion in the corners. It was a lot better. It was passable. Like, I wouldn't rerun the job if it looked like that, but it still wasn't perfect. The last print, the final one that you saw that had no over extrusion anywhere on it, that the extrusion was consistent across the whole part, that's the one that ran with this G-code, where we waited for the full 25 minutes. We did the auto bed leveling, and the part cooling fan was off. If you're really trying to print the fastest Benji you can, go ahead and leave the part cooling fan on. You're printing in such a small area in the center of the bed. You know, if you want bragging rights on how fast you can kick a Benji out, leave it on. I don't think it's going to impact your print that much. But if you're printing on the full bed, or you're printing a larger print, the type of print that you would go to this printer to do, you don't really want that part cooling fan on. And I hear you. That sucks. It came with a part cooling fan, and I'm telling you not to use it. But if you do, the bed's going to move another thousandths of an inch whenever that thing kicks on. So it's going to have an impact on the print. Well, guys, I know this has been a pretty technical video, and it's been pretty long as well. So thanks for sticking with me, up to this point. I really wanted to get this content out there to the community. There are so many people in the community that have already done so much work in getting these Neptune 4 Maxes tuned in, the type of work that honestly ELEGOO probably should have done before they shipped them. Thank you to all the people in the community that have also done a tremendous amount of work to get this printer into a much more usable state. And let me know down in the comments, if you own one of these printers today, how do you feel about this? Knowing that you have now a 30-minute start time before a job even runs to get consistently good prints out of this printer, particularly if you're going to use the whole bed. How do you feel about that? Again, for me, I'm okay with it because I'm not running small jobs on this printer. Anything that I'm going to print on this machine is probably going to be a 20+ hour job anyway. Tacking 30 minutes onto the front end, I just don't care. It's not a big deal to me. And also, if you're in the market for a large format printer, after watching this video, let me know down in the comments as well. How do you feel about that? Does it change anything for you? Hopefully it does. if you were looking at this as, you know, like a buy once, do everything printer, because again, I don't think it's a great fit for that. But if you're looking specifically for a large format printer, I think, you know, value for the dollar, this is still a very good machine. But again, let me know down in the comments what you guys think. And I have one favor to ask of you guys. If this video was at all useful to you, if you got something out of it, if it helped you fix your printer or it helped you make a buying decision, take a second, hit that like button. And if you enjoyed this content, consider hitting the subscribe button. I do all functional printing and engineering stuff like this on this channel. We don't do any like multicolored garbage of the week. It's all functional 3D prints and all the engineering that goes into that. Go check out some of my other prints, and if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.